Okay, we're going to talk about completing the square. Think about this first problem, which is probably super easy. Completing the square. So this, most people will say, oh, that's x equals to 2. But when we take the square root of both sides, we do this, those two operations cancel each other out. They're inverse operations, so the square root of x squared will be x. Over here, it is 2, but it's also negative 2, because negative 2 times negative 2 is 4. We typically take what's called the primary square root, but occasionally we want to know both answers. So to indicate that, we'll do plus or minus 2. That indicates positive 2 is an answer, 2 times 2 is 4, and negative 2 is an answer, because negative 2 times 2 is 4. So a similar problem, what about x squared is equal to 5? Which many of you will be like, but this does have a square root. It's not one that we typically know, but if I take the square root of both sides, okay, that will be x is equal to plus or minus the square root of 5, which is a number. It's an irrational number because it's not a perfect square root. So we do know that. When we look it up on our calculator, we get this big, long number. So if I do 5, clear, second square root 5 on my calculator, I get this big, long thing. I don't know if you can see that there. It's 2.236067977. This goes on forever. And so we end up having to round this and say, well, this is about 2.2. Okay, it's still a plus or minus. But that's irrational because the original number can only be written in that form. It can't be written as a ratio, which is a rational number. It can only be written as a rounded number. So if we write it this way, it's an estimation. The original number is irrational because we have to write it down as an estimation unless we leave it in our calculator or just leave it as square root of 5. But it does have an answer, okay? As opposed to if there's a negative underneath the radical sign, there is no answer, which we're not going to get into for this part, but it is possible you could do that, in which case, in that case, you do not have an answer. If this was x squared equals negative 5, there would be no answer. There's no real solution. All right, where are we going with this? Well, what if I gave you x plus 3 squared equals 4? Basically the same steps. I'm going to take the square root of both sides. So that's x plus 3. When I take the square root, those cancel each other out because they're inverse operations. And this is plus or minus 2, which means this actually has two answers. When I subtract 3 from both sides, I get x equals negative 3 plus 2 and minus 2, which I can break apart if I want to. X equals negative 3 plus 2, or x equals negative 3 minus 2. And oftentimes we'll put an or in there. So that has two answers, x equals negative 1 or x equals negative 5. Both those answers work in the original problem. Negative 1 plus 3 is 2, 2 squared is 4. Negative 5 plus 3 is negative 2, negative 2 squared is 4. Both work. All right, let me give you one more example. X minus 6 squared equals 5. Okay, same process, same problem. We can see immediately when I take the square root, I'm going to get a irrational number, but this is solvable. Okay, so square root, and I get x minus 6 equals plus or minus the square root of 5, which I can leave that way or write as 2.2. So when I add 6 to both sides to get my x alone, I get x equals 6 plus or minus square root of 5, which depending on how I'm supposed to write the answer, that might be acceptable. Those are two answers, 6 plus some number, 6 minus some number. But if I actually estimate it, it's x equals 6 plus 2.2 or x minus equals 6 minus 2.2. So that's either 8.2 or what's that going to be, 3.8? And both those, when I plug them back into the original, they'll get me very close to 5 because I'm rounded them. They won't me get exactly there. All right, so this is an important idea that if we can get to this form, we can solve it. Pretty straightforward. Problem is getting to this form. So let me show you a different problem. So if I've got x squared minus 10x plus 25 equals 7. Now this is actually x minus 5 squared equals 7. But first of all, how do I even know that? How do I know this and that are the same thing? Well, first of all, I can multiply that out and go backwards to this, and it is the same thing. But if I've just got this here, it's like, well, how do I know I can go from here to there? And this is one way you know it. Whenever we factor, if we're just going to factor that, we can use our area model. And we know an x squared has to go there. So an x and an x goes there. And we know a 25 has to go there, so 25 is there. And then I'm supposed to get negative 10x, and it multiplies to 25. I'm like, oh, well, that's a negative 5 and a negative 5. And then that's a perfect square, because the side of this square and this square are the same length, so it's a perfect square. And that's our goal, same length on both sides. That's a negative 5x. That's a negative 5x. Middle terms add up. So this is a perfect square, both figuratively and literally. So we can get that. But very oftentimes we won't get this equation. We will get an equivalent equation, which is this. X squared minus 10x plus 18 equals 0. Now, all three of these are the same equation, but they in no way look the same. So if you start off here, how do we get to this? Because we know we can solve this based on what we just did. So can I get it to this form? All right, so the first thing I'd probably try to do is factor this. So if I try to factor this, which is what makes sense, and sometimes you can, it's x squared and 18, so x, and then I'm like, what multiplies to 18? It gets me negative 10. Like 2 and 9 don't work. They're both going to have to be negative. Negative 2 and negative 9, nope. Negative 1, negative 18, nope. Negative 3 and negative 6 gets me close, gets me to negative 10, 9, but not 10. So this is not factorable in this form. This is not factorable. So the question is, all right, I'm kind of stuck. But we can do what's called completing the square. Completing the square says x squared minus 10x plus some number has to be a perfect square. I can always find a number there that will make it a perfect square. And that's going to equal, and I'm just going to move this out of the way. And to move it out of the way, I'm going to minus 18 from both sides of the equation here. So I'm going to get it out of the way. So it's over here. So starting to look a little bit more like this. Okay? And then the question is, well, what is that number? Now, I already know that number is 25, but maybe I don't. So then we can complete the square again. We're like, okay, but we're going to do it a little differently this time. It's a little puzzle. I got x squared. I know this has to be x and x. And I know these two have to add up to negative 10. And I also know I want a perfect square. I want both these numbers to be the same. So if that's negative 10 and I have two boxes to split them between, oh, this has to be minus 5 and this has to be minus 5 because I need it to add up to a minus 10. So notice that number is always half that. And then negative 5 times negative 5, I finish it out. I'm like, oh, that must be what the perfect square is. So if I need this to be a perfect square, 25 is the right number there, because it's from right there, perfect square. But I can't just throw that in. I have to keep my equation balanced. So if I add this in on this side, I've got to add in the same to the other side, or I've suddenly thrown my equation out of whack. All right, now I know this is a perfect square. I can rewrite it as a perfect square. I can simplify this side and get 7. We're back to where we started. And then I just do what I've done before. I take the square root of x minus 5 squared equals plus or minus square root of 7. I do, that's x minus 5, because the square and the square root are inverse operations. They cancel each other out. Plus or minus square root of 7. And then so add 5 to both sides. I've got x equals 5 plus square root of 7, whatever that decimal number is, and 5 minus the square root of 7. And that's going to be, I think, like 2.5 maybe. I don't remember what it is. Okay, oh, it's 2.6. Okay, so this ultimately is 7.6, because that's 2.6. Or if I 5 minus 2.6 is 2.4. All right, so that's that. So let's do one from scratch and see if we can't figure it out again. We're just going to get it to this form, and then I'm going to stop right there and assume you can carry it from there on down. We've had enough examples of those. So let's say we have the equation x squared minus 6x plus 5 equals 0. Now this is actually factorable. but I'm going to pretend I don't notice that. For whatever reason, I can't figure out what the factors are, so I'm going to do the same process. I'm going to say x squared minus 6x plus some number is equal to, minus 5 from both sides, negative 5. So I don't need to draw this box because there's a little pattern here. And once you figure out this pattern, you can get away from this little box. X squared, we know we have to have minus 6x in both these. So to make sure they're equal, it's minus 3x and minus 3x. Notice once again, half that number there, and this number is that number squared. So notice this is always half that number, and that half that number squared is this number. Half of negative 3 squared is 9. Half of negative 6 is negative 3. Negative 3 squared is 9. Same thing happened up here. Half of negative 10 is negative 5, and 5 squared is 25. So that pattern will always happen, and if you can pick up on that, you can skip the boxes over here. Now, did 9 on this side, got to remember to keep my equation balanced. Now this I can write as a perfect square. It's x minus 3. Notice the pattern again there. This number's half that. This number is this thing squared. Half of 6 is negative 3. Negative 3 squared is 9. Equals 4. And I'll just go ahead and finish this up real quick. So we take square root of both sides. Okay, square root of both sides without actually showing the square root is x minus 3 equals plus or minus 2. I just took the square root of both sides, didn't show that step. Add 3 to both sides. 3 plus or minus 2. That means x is equal to 5, or x is equal to 3. Minus 2 is 1, 5, 1. Oh yeah, if I had factored it, it would have been x minus 5 and x minus 1. Should have noticed that to begin with. This is x minus 5 times x minus 1, which means our solution are 5 minus 5 gives me 0, and 1 minus 1 gives me 0. But I can get it this way too. It was a little more work, but if I didn't see what that was, completing the square will always work.